Okay, Kermit Weeks here, Fantasy of Flight in Roanoke, Texas on my epic trip, and I'm looking for a friend's engine shop and house. This looks like it might be it. Jeff Blakey, engine service. Yeah, this is the right address. And I want to stop here. I haven't seen him in a while. They did a bunch of engines for me. He did Boeing 100s. He just did my original duck engine. Anyway, I haven't seen him in a number of years, and I thought I'd stop by and see what's here. He and his dad used to do big engines, Blakey engine service out of Florida, and his dad retired. And Jeff, it's my rig right there. How about that? Hey man, what's happening?
Long time no see.
I know. Awesome. Good to see you, man. Awesome. Good.
How you doing?
I'm doing awesome. Super. Say, I hope you don't mind doing a little bit of videoing to see what's been going on. And I got some.
Come into my office.
Good. Oh my God. Whoa. Now that is a classic shot. That is me. My first solo B-17 flight as a captain out of Junior Birchinall's dirt strip, and about probably a minute after that we lost number 3. It was friggin' heating up, went to feathered. It was a gear down ferry from Birchinall strip to the other side of Paris, Texas, and Cox Field in Paris, Texas, and anyway, went to feather, it wouldn't feather. So I'm like 800 feet, geared down, one windmilling, or not, anyway.
What do you windmill? It was dead, wasn't it?
It was dead. And then when we got over there, we got the video, we sat there and undid the sump, and you had like a little metal bucket, and all of a sudden the oil starts coming out, and all of a sudden it's going clunk, clunk, clunk.
I had to stick a screwdriver in it to get any oil to come out because it was so clogged with mud. It was a joke.
Oh my God. Anyway, for my little viewers here, so basically what kind of engines and stuff do you work on?
Strictly radial.
Yeah, okay.
Anything radial, pretty
Wrights,
much.
Pratts?
Wrights, Pratts, Lycoming, Continental.
Huh.
You and I, we've talked about the Jap engine, I think, at one point, possibly with the Zero. One of the Jap engines you and I had talked about.
Okay.
Which is a radial, it's a copy of a Pratt. So.
Like an 1830 thing. That's why there's only one of the original Sakai engines flying. Interesting.
My office.
Your office, okay. All right. Yeah, so, God, I think what would be really interesting is just kind of going through, kind of the process of what you work on, tear down, what needs to be done with like cylinders and what some of the different machines are. I think that's a honing machine. I got one of those.
2 of them, yeah. Barnes drills.
Huh.
Early World War II shit.
Oh my God. Harnesses. Yeah. So, just...
We'll start at the back, which is where they come in at. These are all engines on racks that get disassembled. Come in the back door.
Okay, cool.
Unload here with the hoist. Put them in a stand, like over here. These are engines, one's being repaired, the other's being disassembled.
Is that an actual mount off the airplane, or is that just something you've picked up that you use for?
It's actual mount off an airplane, but it's been modified for the.
Oh, I see.
It's a Lycoming. With Lycomings, you have to take the mag and distributors off in order to get it on the mount. So what we did is we modified the mount where I could put the engine on it without having to take that stuff off of it.
Okay, so this is yours. This didn't come with the engine.
Yeah, no. This is. I have QEC stuff basically, or engine mounts for every engine that we run.
So is this 300?
That's a 225.
Oh, 225. A Continental.
That's
like on a Lycoming.
Front, yes, Lycoming.
Okay.
And then that's the Continental. That's a 220.
So what would this go on? That goes on a Stearman. Oh, this goes on a Stearman as well?
This would be the Navy airplane.
Oh.
Army's had the Continentals.
Oh, I'll be darned. Yeah, they all got to be different. Oh yeah.
This had the exhaust on the front.
Yeah,
looks more like an old antique airplane.
And this one's got the exhaust on the back.
Right.
Oh, and it's got 2 more cylinders too. It looks like.
7, 9.
Huh.
This engine's designed more like a right, whereas that's just an oddball. Timing on this engine's done by gears and dots. That has serrated timing on it, so you have to use a timing wheel. Check the degrees of rotation for intake and exhaust opening, and set it. Check it again, reset it till you get to what the book calls for.
So that's the kind of
1340.
just like a little blower section?
Yeah,
or?
that's the accessory section. It's in here because of this.
Huh. And
Bearing failure.
oh yeah, okay. Yeah, let me turn the light on. Yeah, you can see. Oh my God. So are these like babbited, or are they
Silver.
silver?
Mhm.
Silver babbitt?
Yeah.
Yeah. Okay. Huh. And interesting.
They
So
did not lose the crankshaft.
I was just going to ask you what happened to the crank, because the babbitt is softer than the crank, and so,
Yeah, but this is what.
but if it heats up, then it can mess up the crank.
That's out of an 1820. That
Huh.
had a failure also. It'll eat them up.
I'll be darned. So when you say eat them up, you're actually losing metal.
Oh yeah.
Yeah, yeah.
Spores and
I'll be darned. Huh. And then is this, the crank looks like it's probably in 3 pieces?
two.
2 pieces. Oh, I see. So this is probably separate counterweights.
This is another one here that the same thing had happened to.
Oh, that's the front end. Oh, yeah, okay.
See
Oh,
how-
yeah. Now, is that savable from the point of view of, like, you know, grinding it down and replating it, or?
You can't plate a moving surface.
Oh, yeah, that would make sense.
I mean, you can plate here, plate on this journal. Can't plate this, can't plate that, because that's their spinning and bushings. If they're fixed, you can plate them.
Oh, I
But you
see.
can't have rotating. And see, that one there had failed. That's the crank, the master rod.
Right, so they call this the master rod. That's the main one, and then all the other
rods off of it.
other rods off of them. So yeah, that's interesting. And then, so this is the second piece of the back of the crank, and that clamps on there. So what?
These have floating weights on them, as
Right.
opposed to fixed weights. Like the Pratt one has a
And
fixed.
so, just out of curiosity, is the only thing that holds this thing on here and keep it aligned? Oh, I see. It's got a pin
No,
there.
No,
No,
that's oil passage.
that's
The only thing that holds it
passage.
together is this bolt here clamped on there.
That's it. I mean, do you put some like Gorilla Glue on there or something?
No, you have to.
Really? Because, well, I guess my question is, do they ever get out of a line?
They can usually on a sudden stoppage or something they'll twist,
Oh,
but
okay.
normally not running.
Okay.
And like that one here was in a crash, a loss of power, and this is a case that I changed on it. It broke the case because the mag bolts
Oh
on
my
there, so
God,
when it
yeah.
crashed. So what we did is we checked the crank out, put a dial indicator on it, check the run out. And I'll show you later up front there where we do the runouts on the cranks to set them where they're in line. Because if they twist a little bit, then the tip of the shaft's going like that. So you run an indicator out there on the tip, and you keep twisting it till it finally lines up in line, and it's
Okay.
straight. And you
That-
have like a 0 to 6,000 tolerances is all. So we did that
Whoa.
on this one. It didn't twist. I've had other ones that, like one guy had on T28 had a nose collapse on him, and he was under power.
Right.
It twisted it.
Yeah.
So we had to take the whole engine apart and go
Right.
back in and
Huh, interesting. So it's just the
Clamping.
compression on the deal, and obviously that's done dry. There's no oil.
oh, I have to clean it off with like acetone or something. Can't have, because when you slide the master rod over with the lubricant on it, you got to make sure that both surfaces are very dry.
Yeah, okay.
And then that way you don't twist. And sometimes you'll get them in here where the rear part of the crank is shattered a little bit because over a period of time with vibration, they do work. So sometimes they work enough where they just scrap the crank.
I'll be darned. Oh, that's, I think it'd be fascinating for any of the viewers here that any kind of failures and things you have. If you have like examples of things like that, I think they'd be fascinated.
Oh, I keep oddball stuff like you wouldn't believe.
So this tool here is specifically for aligning the
This one
setting the crank up,
I
or?
use just for teardown.
Oh, okay.
I have like 3 up front where I use for different engines to do the runouts. But this is strictly for disassembly.
Okay.
But I have more up front that we use. That's why everything back here is all dirty, because it's all disassembled.
And like all these up here, I mean, what are all these tools?
Pullers, pushers.
Okay, yeah, okay.
For various engines. You know, all the cabinets are full of tools for the different engines. You know, some things can be used on all engines. Most of them are specific for model of an engine.
I'll be darned. So like, you know, this one specifically here, what would that be used for? That's for pushing something out?
Yeah, those would go on the front here like this.
Right.
You'd take the thrust nut off, take these off here, and then the case would be broken. You know, no cylinders on enough, you'd have the bolts out of the case, and it would pull this nose case off the shaft. So that bolts to that, and then you're going down in and pushing on the crank.
So you're bolting on this is here, and as you're cranking down here, you're pushing on the crank, and this is coming up.
Exactly.
I see. Okay. Cool. Okay.
And the Pratts are like that, and the Continental, a lot of the different engines.
A lot of special tooling, so don't try this at home.
After on racks, this is where I all the various hardware for all the different engines.
Oh my God! So you go back to Silvercad.
Oh yeah, because I have some customers that are very adamant about being period correct.
Oh, I wonder who that might
Even
be.
to the point of using slotted screws and not Phillips.
I won't say who that might be. Cool. All sorts of hardware like oil screens.
We send it out. You know, I got a plenty of shop we
Intake
use.
tube.
Yep.
Nuts.
Do it by the 5-gallon buckets.
So, you know, I have to ask, I mean, hardware is probably not that big an issue, but how much engine stuff is out there, you know, because there's becoming less and less new inventory.
Right.
More people are, you know, there's more and more airplanes being restored. At some point, what's going to happen with...
Well, the sad thing about it, some things there are particular to a specific engine.
Right.
And sometimes there's only one specific bolt for that engine.
Right.
That becomes a problem. I just went through that doing a 2600 with the baffle pieces for the Dash 20 cylinders is different than the Dash 35. And for some reason I got short on those pieces, and I was barely lucky enough to come up with enough for the complete engine.
I'll be done.
Without having to take the Dash 35s and do this, you know, mill work on it to make it like that. So a lot of these boxes, they say a specific to a, you know, an engine and a model of an engine, because there may be only one or two, and then the sources aren't out there anymore to come up with that hardware. So in some cases, you know, I scrounge around, even I have to go over into the warehouse and take a piece apart to get that bolt or nut or whatever it may be off of it to use it.
Yeah, it's like the car thing and airplane thing as well. What happens is you get down to it, you've spent a lot of money on a project, you get down, you got one last thing that you can't find, you're forced to build it because you got its stuff, and then you know, then the price goes up. So there's this dog chasing its tail scenario with you know, the increased cost of restoration and stuff. That's why the prices keep going up.
And we do all our, you know, most of the machine work for all the cylinders. You know, obviously there's the tools for just about any kind of, you know, process to what I want to do. This is one of those parts that we talk about that.
Whoa, okay. So that's a pretty screwed up.
That's off the B-29 when the guys told me the engine never overheated.
Okay. Interesting.
All right, that's, you know, it's a 3350.
Yeah.
The engine had failed, but it had eaten that up so bad, and if you look on the inside, you can see how it collapsed.
Oh my God.
That got hot.
Oh my God. Unreal. And that's a bent rod right there. Huh. Of course, we know about those on
and
the
this I
Stinson.
saved because it was a hose on an installation for an engine that we did on a DC3, and it started for oil, master rod bearing failed and everything. So we got the engine back and firewall forward, and then we found this hose was in the fire sleeves that go on the oil lines, the orange stuff.
Yeah.
This is how it was.
Okay, so it couldn't get the oil.
It couldn't get the oil.
Oh my
But
God.
with the fire sleeve, you couldn't see that crimp in there,
Oh,
and
darn.
I can't even hardly bend that.
303 hose. Right?
Yes.
Yeah.
So that was, look how easy that bends, because they had
Yeah.
forced that in there when they
Yeah.
installed the airplane, coming from the tank to the engine, bend it like that.
And as soon as it gets warm, it gets even softer, so
Yeah.
it bends even more.
And that's an engine I warranted until I found out that it wasn't my fault.
Oh my God. And I'm sure that probably happens a lot. So.
Well, I've had to change my warranties now to where I'll warranty the engine, but I've got to be there when the engine
Right.
started, because I want to see. Because I've also had, I found out on a B25 that an engine that failed after 10 hours. I did warranty that one, but I didn't find out till later that one of the mechanics that I knew from another airplane was involved in it. They had left a rag in the oil line. So when
They did what?
left a rag in the oil line on the airplane.
You
So
gotta be
when they
kidding
took
me.
the engine off, they stuffed the rag in the line to keep it, stuff from getting in it. They never took it out. And they found that out after they had run, because they got the engine running and they couldn't get oil pressure. So they checked it and the rag's good. So they took the rag out and now they fly the airplane. But they had already done the damage on the engine, so it took 10 hours for it to fail. So,
Oh my God. So what are some, point out a tool or two here. Like, I mean, these things are all like, what's that for? Obviously that's for a special thing for
yeah,
twisting it.
there's a nut on the
Yeah.
accessory drive shaft on an 1830, and that takes that off.
Oh my God. And they're all, so.
They're all different engines. Those are kind of like the same for different engines. 2800s, 1830s, R2000. This mainly is Pratt. These fixtures down here are to take the 2800B crankshafts apart. Because
Wow.
what on a 2800, well, now I can show you one I got in here. It has the
So
bolt.
it's just like a puller or something?
Yeah,
Okay.
those are hydraulic rams. Okay.
Oh.
See that fixture here?
Oh yeah.
It's
Oh,
like-
so this is all part of it.
Yeah, it's one whole tool, and it pushes, it goes over the front of the crankshaft, and you have to hydraulically press it apart.
Oh, so you just manually press it?
Yeah.
Yeah. Okay.
But the only problem with those is that the bolt that holds the two halves together has a left-hand and a right-hand thread. So there's a gauge when you put it together, like these right here. Let me clean it. In fact, I'll put this.
Oh, so you have to make sure that it's the same pressure so it comes up evenly.
Well, what you do is you have to get both threads started, because it works like a turnbuckle. You turn one way is off and on, but you have a left-handed thread and a right-handed thread over here.
Right,
So the two pieces coming together, the threads at both ends have to start at the exact same time. Now, because when they come together, it has to be at that specific point. Whereas the turnbuckle, if you start one side versus the other, it's not really a big deal thread off, because you're not bringing the center together.
Right.
The crankshaft, you're bringing the center together, and the bolt has to be at the right place at the right time to be completely together. So you start it with this gauge, you put it up there, then you get the bolt started, then you put this up on there, and it's a no-go. And that tells you how far, if the bolt is within that no-go, then you know both ends are started.
I'll be darned. Oh my God.
And who would think of something like that?
Oh my God. So
Pratt and
anyway.
Whitney, because they're tool and die makers. Whereas Curtiss Wright are so simple because they were bicycle makers.
I'll be darned. At least the right half of them.
Yeah. But that's how the thinking goes to the. This would be the cylinder shop. We do
Okay.
all their cylinder work.
So when you say all our cylinder work, so when you pull off a cylinder, what exactly are you doing? You're grinding valve seats, you're honing cylinders, what do you actually check? When an engine comes in for overhaul and it's wearing out, what actually, oh my God, look at that valve. That's got to be an intake valve, exhaust valve. Has this got stuff inside of it?
Sodium filled, yeah.
Sodium filled, yeah. Yeah, so actually when they do the valve here, I think they put it together and they either weld this together or something, but they basically, the inside of that is not metal. It's actually got sodium in it. And I think,
That one's exhaust, but intakes and exhaust on, this is an 1820.
okay.
These were all new valves. Most of the cylinders are new for this one specific customer. But what you do, you'll bring an engine in, a cylinder in. I don't have anything that's out, but what you end up doing is you take the valve guide out of the cylinder, which,
Yeah, just lay it on a bench somewhere so we could kind of see what.
well, I could show you
Yeah, okay.
one.
Yeah, okay.
what we do.
So any fancy tools? So that's just mainly kind of a fancy drill press.
I do some, you know, machine work there.
It's for grinding a valve.
These are all specific. This is a Van Orman valve grinder. It does big valves. You know,
Okay.
I used to have a little one.
So probably hooks in there.
3/4 inch stem.
Whoa.
That's what that is.
Oh my God. But that's not 3/4. That's like half.
No.
When you say 3/4, I mean.
0.750. This is probably 0.745 is what this should be. The gap.
So we got a mic right there.
746.
I'll be darned. Huh. So what they're doing is they're putting on, they're grinding this angle right here.
Yeah, that goes in there.
Like that.
Yeah, the machine basically is set.
Grinds it right there.
Yeah, so it goes there like that. And then you can change the degrees.
Right.
Like, because on the rights, some of the earlier ones were like 38 degree, not 45s. The later ones are 45s. Pratt's are 45s. And actually the rights are not 45s. What the rights do is they have a 44.15 and 44.3, you know, whatever, 3/4, so it would be 75.
Huh.
So what they do is they figure a work-in angle rather than an angle together, because basically if you think about it, as it's wearing, you have a different angle. It's always wearing in. Whereas if it's 45, it's wearing, it's not wearing, you know, like.
Right. Okay. So, and normally on an engine overhaul, like on a radial, how often do you have to grind the valves? And then also too, you have to do the valve seat, which is in the cylinder.
Right. When I overhaul them, that's 100%.
Yeah. Okay. So I mean, but how much time before you? 1,000 hours, 1,200 hours, 800?
It really depends on the operation.
Right.
Fuel. There's so many factors. If you don't keep the valves adjusted properly, you'll get a lot of valve slap, and then that wears the seat out big time.
Oh, okay.
Plus the stems wear, which on this end of the machine, you put it in here and you grind, you know, that because they get, you know, wear spots on them.
Oh, because the cam's hitting it right there.
The rocker arm is
the rocker arm. Yeah.
And if you get too much in there, the same scenario, you get a lot of slapping, and then that's what you get to wear.
Interesting.
And then that machine over there, you bolt the cylinder in it, and then do the seats.
Yeah. Okay. So this is actually in the cylinder that you're.
Yeah, you mount a cylinder up on here, flip it upside down, and then you can go down inside, and then that's what this tool does. You know, you put a stone onto the seat, which is like, this is a.
So, but it has like it has a guide. You're using the hole in the cylinder as the guide.
That's a seat.
Right. Okay.
So there's your stone. So you grind that.
Okay.
Yeah.
So,
you take these are all pilots, and they're for different sizes for different size guides.
Right.
So you ream the guide on one of those machines over there, and then you bring it over here. You put that in there. You take the stone. You do the same thing. You dress the stone to whatever degree you want. I happen to have a whole bunch of stones, so I don't like to regrind a stone to one thing or another. It's these are 45s or those are 38s or whatever. So I'm able to keep that kind of a supply up.
That's interesting. So then
these machines here, what these do.
When he's saying the valve seat, you're talking about. Down inside.
Here, let me get a better. I got one over here.
So the valve goes inside the cylinder this way, and the stem sticks out the top. How about on the stool right there?
Well,
there we
go. Set it in the machine.
Yeah.
It's set up for a different cylinder. See, those have been ground.
Okay, so basically the valve sits in there. There's the seat. And so how does the seat actually fit in there into the cylinder, which is a separate part?
There's this interference fit.
Huh. And obviously, you know, depending on the metal, they have different expansion rates, and so you have to take that into consideration, because the aluminum cylinder, which is cast, is going to expand at a quicker rate than a steel piece like that.
Well, some of them, and the early ones were screwed in seats, which they went away from that on Curtis Wright. The Pratts have a lip on them where you put them up in there and then you roll the top side rolls over inside the seat, or inside the port, to keep them from coming out. Wright's, this one seat here is something they went to because that became a factor of dropping a seat in a cylinder. They put copper backing on it.
Oh, which is going to be a different expansion, right?
Exactly. It has a better retention to the aluminum. And then what they did is they pinned that so that the stylight is pinned to the copper. So that goes up in there. But again, you have an interference fit. Like the boss where the seat's going into is smaller than this.
Right.
So they
heat it up.
I have a thing out there that we heat the cylinder up. It expands. Usually put these in the freezer or nitrogen, liquid nitrogen, and then you got a tool that holds it, and you pop it into the cylinder.
I'll be darned. And somebody's had to figure this out over time, and probably including some failures too. So.
Yeah, I mean, it's all with experience of doing it.
And just out of curiosity, I see some big springs up here for the valves and stuff. So do you have? Is there? I would assume they could deteriorate over the time, or if they overheat. Blah blah.
Yeah.
So you actually test the.
Yeah, there's a.
So actually, okay. So that's a good question, Kermit. So you put that on there, and you actually just put the spring in there, and you test it for, like
whatever the book is. You'll set the height of the spring.
Right.
Free height.
Right.
And then at a certain compression distance, you set it for whatever pounds. So you would zero it, and then you'd compress it to that point, and you need to be within whatever the range the book gives you.
I'll be darned. And the reason they filled these with sodium was for just heat transfer, or to keep them from getting too hot.
Yeah, it's strictly for heat.
Yeah. And so, just out of curiosity, you haven't got a valve that's busted open, you can see the inside?
I might. I would have to go there and look at my gallery.
And I'm thinking, for some reason, one of the really, really early engines that started doing that was the Wright J5 on the Spirit of St. Louis. Is that right?
I'm not sure.
Because I think those are sodium-filled valves, and they're like rare as hen's teeth, and I think I bought a whole pile of that stuff. Well, I don't know how many valves I got, but
I know back at my dad's, he was part of a company way back, Design Engineering Trans Supply, and they were on one of those little lakes there in Miami off of 57th Avenue, which we used to go get crabs. Well, when I was young, some of the guys would take the scrap valves. You would take a hacksaw and cut the stem till you got the, sodium exposed.
Right.
Chuck them in the lake. Boom!
No way!
Yeah. Some of the things I learned when I was a little kid, these old guys would do that. They'd sit on this one place there, which I think the lake's filled in now. But when I was young, they used to do a lot of blue crabbing over there by the airport, off of by 94th Aero Squadron. But we used to sit out there.
And the crabs would be cooked when they floated to the surface.
Man, it was the first time I saw it just freaked me out. But that just tells you the volatility of the sodium to moisture.
To water. Water is what sets it.
Water is what makes it. I guess expands it so fast that it blows up. But they would cut the stem, chuck it out in the lake, and when it hit that water, it would just blow up like. Boom! Be like throwing like an M80 out in the water. So anyway, that's how.
All right, valves are too valuable these days, guys. So don't try that at home.
Yeah, don't try that at home for sure.
Unreal. So like this tool here looks like some kind of a.
Yeah, right here. This is a 2800B cylinder off of a A26.
Okay.
And the connector that came off of it was cracked. Okay. Let's see if you can see that in there or not.
Okay.
But.
All right.
That was cracked and loose. So.
And that's how you found it, because it was loose.
Right. Okay. The mechanics on the aircraft. So then what we did.
Is this actually the one that came out of? Because you can see there's metal filings.
Well, yeah, because what we had to do.
Oh.
We had to go back in there and tap it.
Is this tapped oversized?
Oh yeah, this is plus 100. So
100,000. So it's 50 thousandths
per side.
And how much? That's it.
This is it. Or the cylinder's scrap. If this doesn't work, which it does. This is a plus 100.
Okay.
So we've had tap the hole out, get all the threads cleaned up. Still got a little bit more work to do on it, and then we'll put the
so this is a separate piece right here.
Yeah, this is the tool.
There we go. Okay. Too cool. So that just screws in right there.
Mm-hmm.
Unreal. Oh my God.
And that's the tool to put them in with. So, and it's got those little notches in there that the tool catches on.
Right.
To do it.
Fascinating. Yeah, I'd still like to see the inside of one of those valves.
See, that's a Pratt. It's not sodium filled.
Yeah. This would be intake?
Yes.
Yeah, because the intake valve doesn't get as much heat as the
right,
exhaust
but some
valve.
of the bigger ones, like this is off like a 2600, and so the 2600 was really an earlier engine, whereas as the time went on, you know, mainly the 1820s, 3350s for sure, all went to sodium filled valves, both of them.
I'll be darned, huh? I just to dissipate the heat.
Yeah,
so this thing here, he's got a jig here to hold the cylinder to do some kind of drilling for
exactly.
for something.
Now these machines here, this one here reams the bosses in the cylinder where the valve guide goes. So when you take the guide out of the cylinder, you know, take the guide here out. Okay, you take the guide out.
Okay, so this whole piece in here.
Yeah, you take it out, and now you have the boss in there. So now you got to put a brand new guide in it. So now what you do with this machine, you set it up, you can cut the boss itself to expand it, make sure it's true, because the seat sits on here.
So obviously the cylinder fits in there and there's some funky angle. So the cylinder's like this because the valves are like that.
This clamps it. It's all air operated and hydraulic. So it clamps it together, holds it concentric to the seat. And so then with this you can set it. This is what's good about this machine is I can cut a cylinder by the thousandths, whereas originally the manufacturers had reamers for plus sizes.
Oh my
so
God.
you'd automatically
Right.
knock 5 thousandths out at every time.
Right.
Where here I can cut, you know, as little as
Yeah.
half a thousandths out, because what this is a little, you can see the
Right.
you know, I
Oh
set
my God.
it originally the cutter, and then I can adjust it to whatever, and then I can cut it out till it finally is true.
I'll be darned. Now is like one for intake, one for exhaust?
No, this one cuts the boss of the cylinder for the guide. Once we put the guide in the cylinder,
Right.
you set it on here, and you ream the guide to fit the valve. Same
see.
thing as I have reamers all different sizes. I can take a valve that's got 1,000ths to 2,000ths wear, and I can cut the guide to fit the valve. So I always maintain a minimum clearance with a used valve, because see, if you punched it out to the size that it's calls for, say like 750, okay, and you have a 746 valve, you have the right clearance. But if you have
4,000ths clearance.
yeah, 4 to 6.
Okay.
So if you have a valve that's worn 1,000ths or a couple thousandths, but it's still good,
Yeah.
you can't use it with a standard reamer. You have to go to the next size. So
Right. So you can just expand out as you need to.
Exactly.
And these
So-
are all just different tools for different cylinders and engines.
And see what with these machines, you keep the stuff around, okay? Because valves and stuff like that, they don't make them anymore, and you can't realistically make them. So you in order to keep them, you have to be able to use them at those little increments. Instead of going 5, 10, 15, 20 before it's no good.
Okay, so let me ask you something. There are not more and more, there's fewer and fewer engine shops. And so do these tools get scrapped? Do people pick them up?
Well, the thing is, there's really not, there is the work out there, but it's not like it used to be.
Yeah.
So that's dwindled down. So now you have most of the shops that are left now have the tools that they need. So all this other stuff, unless you have somebody specific that comes to you and says, hey, I got this tool, that tool, is it any good? And then you can buy it.
Right.
Otherwise, nobody wants it. It goes to the scrap.
Oh my God.
You know?
Oh my God. Well, it's basically.
That's what happened with my dad's stuff.
Yeah. It's the same scenario as the airplanes. They used to be thousands of P-51s, but nobody wanted them, so they scrapped them, and that's what's happening in the deal there. And I guess the biggest thing is these types of engines aren't really commercially used anymore, except for a couple of places like Buffalo Airways and and stuff. So it's like, so it's really the vintage guys that are keeping this alive.